a 1 kilo ohm resistor, a 0.6 kilo ohm resistor, and a 3 kilo ohm resistor. We have an inductor and a capacitor, and we're supposed to determine the average power dissipated in L. So one way to do this, and a nice way to do this, is to figure out the average power dissipated in L, is to reduce everything over on the other side to its Thevenin equivalent, and then from that you can figure out what the power is. So let's start by, whenever you have a situation like this right here, a source transformation is a nice way to simplify that. So you can change that to a current source that is V over R1 in parallel with the resistor that is R1. And then I have this next resistor, which is R2, and then the inductor, which is ZL, and then the capacitor, and then I have RL here, and this is ZC. So then I can combine those two resistors in parallel. So I have a current source that is V over R1, and then this resistance is R1, R2 over R1 plus R2. And then I have ZL and ZC and RL. And then I can take this back to a voltage source, and this voltage source is going to be this voltage times this resistance, so my R1s will cancel out, so I get VR2 over R1 plus R2 times R1 R2 over R1 plus R2 and ZL and ZC and RL. So now I can combine these two, so VR2 over R1 plus R2 is my voltage source. And then this impedance is R1 R2 over R1 plus R2 plus ZL. And then I have ZC. And RL. And then now I will put some numbers in, because at this point I'm more likely to make mistakes with the algebra than with the numbers. Up till now I was more likely to make mistakes with the numbers. Do I not have the voltage? Let's see, the voltage was supposed to be the voltage was supposed to be 100 angle 0. So that is 37.5. This is 375 plus J800, and ZC was negative J500. So this would be, as a current source, would be 37.5 over 375 plus J800. And then I have in parallel 375 plus J800 with minus J500. So 375 plus J800 times minus J500 over, if I add those together, I get 375 plus J300. So in parallel, those two impedances are I get 406 minus J825, and over here I get .018 minus J.038. And I get, if I turn that back, I get so if I turn this back into a voltage source, I get negative 24.39 minus J 30.49 and this was 406 minus J825, and our load was 3 kilos. Okay, so did I give y'all this formula for power? Oh yeah, we just had it just a minute ago. So that's the formula for power. So so I now know. Let's see. So I've got. I can get the current by taking my voltage times my total impedance. So the current, or divided by the total impedance. I don't know why I still do that every time. 24.39 minus J 30.49 over 406 plus 3,000 would be 3,406 minus J 825. And that is minus 0.0047 minus J 0.01009, and in polar that is 0.0111 angle negative 11, no, angle negative 115, but we only need the magnitude of it, so the power will be 1/2 0.0111 squared times our load, which was 3,000, which is 0.186 watts, which is the right answer. Okay, so questions on that one?
Could you scroll up a little bit?
Uh-huh.
One. Okay.
And I am going to have to stop after this. Did y'all make a sign-in sheet for me?
Yeah.
Okay, great, thank you.
Thank you.
Any other questions? All right.